When you look at a map of Earth, something strange happens. Your brain accepts it instantly. Continents are where they are fixed, permanent, written into geology itself. We learned this in school. We absorbed it without question. And for most of your life, you've never thought to question it. The idea that the ground beneath our feet, the very continents we walk on, might have been completely different just a few thousand years ago. This thought doesn't naturally occur. It's not because the evidence isn't there. It's because we've been trained not to look for it. There's a comfort in certainty. We like our world mapped, classified, solved. It allows us to sleep at night, knowing that someone, somewhere, has figured things out. Scientists, historians, archaeologists, they're the ones who know. They've studied the evidence. They've published the papers. They've reached consensus. And we accept their consensus because questioning it feels like standing against the entire edifice of human knowledge. But what if that edifice has gaps? What if it has blind spots so large that entire civilizations could fall through them? The story we're about to tell you is about something that shouldn't exist, at least according to modern science. And yet, the more you look at the evidence, the more you begin to wonder how we could have missed it for so long. It starts with a simple observation. Across the planet, separated by oceans and centuries, ancient peoples told the same story. They spoke of a sunken land. They described advanced civilizations lost to catastrophe. They preserved this knowledge in their sacred texts, their monuments, their myths. We called it mythology. We dismissed it as fantasy. We filed it away in the same mental category as unicorns and dragons. But here's what's interesting. The locations they describe match. The technological sophistication they mention aligns. The timeline they suggest, when you look at actual geological evidence, begins to make a kind of terrible, beautiful sense. What if they weren't making things up? What if they were remembering? In 1872, a scientist stood up in front of the scientific community and made a prediction that would have changed everything. Based on observation, logic, and careful analysis, he proposed that a vast continent must have existed where the Indian Ocean now lies. The evidence seemed compelling. He'd worked it out carefully. But something peculiar happened. Instead of investigation, there was ridicule. Instead of exploration, there was dismissal. His name was gradually forgotten. Not because he was wrong, but because his idea was inconvenient. It challenged what people had already decided to believe. What follows in this documentary is not a journey toward fantasy. It's not a descent into conspiracy thinking or pseudoscience. It's something more unsettling. It's an examination of how we became blind to our own history, how we created narratives that, once established, became nearly impossible to revise, how entire chapters of human civilization could be forgotten, not because evidence was lacking, but because we'd collectively agreed not to look too carefully. The question that drives this investigation is perhaps the most important question in archaeology, in geology, in history itself. It's not, was Lemuria real? That's only the surface. The deeper question is this. What else have we decided not to see? And what might we discover if we simply began to look? In the 19th century, there lived a man named Philip Sclater. He was a naturalist, not a mystic, not a dreamer, but a careful observer of the natural world. In 1864, while studying the distribution of lemurs across Madagascar and India, he noticed something that shouldn't have been possible. These creatures existed in two locations, separated by thousands of miles of open ocean. According to everything we knew about how species evolved and spread, this was inexplicable. There should have been a connection between these populations. There should have been a land bridge, or better yet, a continuous landmass that allowed them to migrate and populate both regions. His logic was impeccable. His methodology was sound. Sclater proposed that a great continent must have once existed in the Indian Ocean, a landmass that had since sunk beneath the waves. He called it Lemuria. The scientific community took notice. This wasn't dismissed as fantasy. Respected naturalists, including the great T.H. Huxley, entertained the hypothesis. It seemed plausible. It solved puzzles that other explanations couldn't quite address. But then something changed. A new theory emerged: plate tectonics. And as this new framework gained dominance in geology, the Lemuria hypothesis became an obstacle, not because new evidence had refuted it, but because a different story had become more fashionable. Institutions have momentum. Once they commit to an explanation, revising it becomes costly, not just scientifically, but politically. Scientists who invested their careers in the new paradigm had little incentive to admit that the old paradigm might have contained valuable insights. Sclater's work didn't disappear overnight, but it faded. It was relegated to the status of outdated theory. His name became associated with a discredited idea. Textbooks were rewritten. The next generation of scientists learned that Lemuria was a hypothesis that had been disproven, even though no such proof ever materialized. What had actually happened was simpler and more insidious. It had been forgotten. There were others who noticed the same patterns. Ernst Heinrich Haeckel, a brilliant naturalist, examined the same evidence and reached similar conclusions. He wasn't alone. But as institutional consensus solidified around plate tectonics, a theory that could explain some geological phenomena, but conveniently didn't require anyone to account for the anomalies that had puzzled Sclater the voices raising, questions were progressively marginalized. What's remarkable is that these men weren't iconoclasts or contrarians. They were careful scientists working with the best information available to them. They made observations, tested hypotheses, followed evidence. They did exactly what science is supposed to do, and for their troubles, they were gradually erased from serious consideration. Their ideas weren't really refuted. They were simply rendered invisible through the weight of institutional indifference. This pattern repeats throughout history. A question gets asked. Evidence accumulates. But if the evidence contradicts what institutions have already invested in, a subtle process begins. Not an obvious suppression that's too crude and leaves too many traces. Instead, the work becomes outdated. The researchers become fringe. The research gets harder to find, harder to reference, harder to build upon. Young scientists learn that pursuing such questions is a path to professional obscurity. The story of Sclater and others like him reveals something important about how knowledge actually works in human institutions. We tell ourselves that science is a pure pursuit of truth, guided only by evidence and reason. And in many ways, it is. But science is also a human institution, populated by humans with careers to build, reputations to protect, and beliefs to defend. Understanding this doesn't make science bad, it makes science real. It makes us understand that being skeptical of mainstream narrative isn't the same as being anti-scientific. Sometimes, the most scientific thing you can do is question what everyone has agreed not to examine too closely. There's something peculiar about the ocean floor. When we began mapping it seriously in the 20th century, we discovered that it doesn't conform as neatly as we'd hoped to our theories about how the Earth works. There are formations that shouldn't exist. There are geological features that tell stories that don't quite fit the narrative we've constructed. In the Indian Ocean, beneath the surface, lies a geological formation called the Mascarene Plateau. To understand what's strange about it, you need to understand what makes a plateau underwater. These features are typically either volcanic in origin, built up by repeated eruptions from below, or they're continental shelves, the shallow regions at the edges of land masses. The Mascarene Plateau doesn't fit either category neatly. Its composition suggests continental crust. Its structure indicates it was once above sea level. Its current depth cannot be easily explained by standard plate tectonics as we understand it. Around this plateau lie isolated islands. The Seychelles, for instance, have a peculiar geological composition. They contain granite, not the basalt you'd expect from volcanic islands. Granite forms differently. It suggests continental origin. These islands seem to be fragments of something larger, something that broke apart, something that sank. Madagascar itself presents an anomaly that nobody adequately explains. The species found there, the lemurs, the flora, the unique fauna, make sense only if Madagascar was once connected to Africa and India through continuous land. Yet the geological story we tell makes such connection implausible. The species are too distinct. The distribution is too precise. It's as if Madagascar were colonized by creatures from multiple sources during a specific period, when different routes were available. When the geography was different, When oceanographers began drilling cores from the ocean floor, they found something unexpected. These cores contain a record of sea level changes. The ocean hasn't always been where it is now. In fact, during various periods of Earth's history, sea levels were dramatically different. After the last ice age, sea levels rose precipitously. But there's something else in those cores, evidence that these changes weren't always gradual. There are indications of rapid transitions, periods of instability, sudden shifts. Continental shelves tell a particular story. These shallow regions surrounding continents show signs of past human habitation. Underwater archaeology has revealed remains of settlements far deeper than current sea levels would allow. Fishing camps, tools, the detritus of human life, all preserved beneath the ocean in places where people couldn't possibly have lived if the sea level were as it is now. When you combine these observations, something interesting emerges. Not proof, exactly, but a pattern that demands explanation. The geological record suggests that there were periods not that long ago, in geological terms, when the geography was radically different. When coastal regions that now lie underwater were habitable. When connections existed between regions now separated by open ocean. When a civilization based on maritime knowledge could have established itself, thrived, and then been utterly destroyed when climate and sea level shifted catastrophically. None of this requires magical thinking. None of it contradicts basic geology. What it does require is that we pay attention to evidence that's somewhat inconvenient. What it requires is that we acknowledge gaps in our models. What it requires is that we ask, what if the maps we were given aren't the complete picture? The truth about geological models is that they're always provisional. They're always being refined as new evidence emerges. The idea that the geological community has settled all the major questions, that there are no mysteries about Earth's recent past, that's not how science actually works. Yet that's exactly how we treat it in popular understanding. We treat it as settled. We teach it as gospel. And when someone notices an anomaly, we dismiss it as ignorance rather than acknowledging it as a gap in our understanding. Imagine sitting around a fire thousands of years ago. Imagine that your civilization had experienced something catastrophic so terrible that it had destroyed everything you knew, everything your ancestors had built. Imagine that only fragments of your people had survived. In the darkness, by firelight, someone begins to tell the story of what was lost, the story of the land that sank, the story that must be remembered. Because if it's forgotten, it's as if it never mattered. This is how myths begin. Not as fantasy, but as memory transmission. Not as entertainment, but as the most important knowledge a culture could preserve, the memory of catastrophe, the warning about the fragility of civilization, the record of what was. Across the world, this story was told. In India, ancient Tamil texts describe Kumari Kandam, a vast, sophisticated continent that lay to the south and east of the current Indian peninsula. The descriptions in these texts are remarkably specific. They describe cities, they describe trade routes, they describe the geography and climate. Most intriguingly, they describe the moment it was lost to the sea, not gradually, but catastrophically, not through decay, but through a sudden event. In Hindu cosmology, there exists the concept of the four ages, the yugas. These are periods of decreasing quality and length, suggesting an understanding that civilization itself is cyclical. Civilizations rise. They reach peaks of development, then they fall. Sometimes they're destroyed entirely. The current age, according to Hindu philosophy, is the Kali Yuga, an age of degradation. But this implies that there were previous ages, previous civilizations, previous peaks of human development, now lost. Plato wrote about Atlantis. But people often misunderstand what Plato actually said. He wasn't writing fantasy. He was describing specific geography, specific technology, specific organizational structures. He placed it in the Atlantic, but we know nothing of what lay in ancient oceans if a civilization existed and was destroyed. His descriptions are precise enough that they sound like he was either describing something he'd heard about from reliable sources, or he was describing something his predecessors had documented. Travel west from Europe. The Polynesians, isolated from other cultures for thousands of years, maintained oral traditions describing their origins in distant lands. They described migrations across vast oceans from regions now lost. Aboriginal Australians, similarly isolated, maintained Dreamtime stories describing a past geography dramatically different from the present. The details in these stories, the locations, the routes, the reasons for migration, are too consistent across cultures to be coincidence. In South America, indigenous peoples described a time when different lands existed, when different people came from across the ocean bringing knowledge, when geography itself was different. Modern archaeologists have largely dismissed these accounts as mythology. But here's an interesting question. What if mythology is simply the name we give to accurate historical accounts that don't fit our current understanding? What makes all of this remarkable is the consistency. Not word-for-word consistency that would suggest copying. Rather, its consistency in core narrative elements. A civilization existed. It was advanced. It was destroyed by water. The destruction was catastrophic and sudden. Some survived to tell the story. The story was so important, it was preserved across generations, across oceans, across thousands of years. When you examine these accounts with the same scholarly rigor you'd apply to any historical document, something becomes clear. These aren't random myths. They're not the kind of stories humans naturally invent. They have the shape of memory. They have the weight of testimony. They have the specific details that genuine witnesses include details about daily life, about trade, about the moment catastrophe struck. The question that's never satisfactorily answered is this: why would unconnected cultures across the globe tell essentially the same story if there was no shared historical experience to create that story? The most parsimonious explanation isn't that all these cultures independently invented identical narratives. It's that they were all remembering something real, something that happened, something so significant that it became central to how these cultures understood their own origins. When archaeologists first examined the Indus Valley, they found something that didn't fit comfortably into the narrative of human development. Cities, not villages, not primitive settlements, but cities with sophisticated urban planning, standardized measurements, and complex drainage systems, streets laid out in grids, buildings constructed with precision. Evidence of trade networks extending over vast distances. The peculiar thing about the Indus Valley civilization is that it appeared without apparent precursors. Archaeologists call this appearing fully formed. There's no evolutionary trail showing how such sophistication developed from simpler settlements. It's as if the knowledge for creating such cities was already present when people arrived in the valley. As if the founders knew what they were doing because they'd done it before. Travel to Easter Island. Consider the enormous statues, some weighing 80 tons or more. Consider the precision required to carve them. Consider the logistics of transporting them across the island. The conventional explanation for how this was accomplished is somewhat vague. We know the statues exist. We know people moved them somehow. But the actual methodology remains unclear. And here's what's more interesting. The statues are only one mystery. The island bears other marks, evidence of sophisticated astronomical knowledge encoded in its geography. Evidence of organization and planning on a scale that seems excessive for a small island population. Underwater archaeology has become increasingly sophisticated, and with that sophistication has come discoveries that complicate the historical narrative. Off the coast of Japan lies the Yonaguni Formation, an underwater structure that displays geometric precision. Its origins are debated. Is it natural? Is it human construction? Geological opinions differ. But the fact that serious scientists question whether it's artificial rather than immediately dismissing it tells us something. The possibility is plausible. Off the coast of Peru, similar structures have been identified underwater. Off Cuba, the Bimini Road, a formation of regularly spaced stones that could be natural or could be evidence of ancient construction. What's significant is not whether any single one of these is definitively artificial. What's significant is that they're not isolated anomalies. They're part of a pattern. The conventional chronology of human development compresses remarkable achievements into a narrow window. We're told that sophisticated civilization emerged only in the last 5,000 years or so. That before that, humans were simple, primitive, incapable of complex organization. Then, suddenly, civilizations appear in Egypt, in Mesopotamia, in the Indus Valley, all roughly simultaneously, all with sophisticated knowledge already present. What if that chronology is compressed? What if human civilization is older than we think? What if there were sophisticated civilizations that existed, that were destroyed, and that the ones we study in conventional history are actually rebuilding attempts, civilizations established by survivors of earlier catastrophe, carrying with them fragments of older knowledge? An underwater city was discovered off the coast of Israel. Archaeological evidence demonstrates it was a real city, with real inhabitants, that was submerged by sea level rise. The dating suggests it was constructed during a period when, according to our current models, humans shouldn't have had the capability to build such structures. But the evidence is there. The city is real. The only thing that's wrong is our understanding of when humans were capable of such achievement. Consider the precision of measurement in ancient monuments. The Giza pyramids display alignment precision that seems unlikely without sophisticated surveying equipment. Yet we're told they were built with primitive bronze tools and human labor. It's possible. Humans are ingenious. But it requires a level of sophistication in planning and organization that we typically associate with much more recent civilizations. The pattern that emerges when you examine these anomalies isn't proof of anything definitive, but it's a pattern that our current models struggle to explain. It's a pattern that suggests our understanding of how human civilization developed might be incomplete. It's a pattern that asks a simple question. Might there have been advanced civilizations in Earth's past that we haven't accounted for? When radiocarbon dating was developed in the middle of the 20th century, it seemed like a revelation. Finally, we had a way to determine the actual age of ancient objects. Not relative dating, not this is older than that, but actual numerical ages. The method was elegant. It relied on the fact that living organisms accumulate carbon-14 at a steady rate. When they die, that carbon-14 begins to decay at a predictable rate. Measure how much carbon-14 remains, and you can calculate how long ago the organism died. The excitement was warranted. This was a genuinely powerful tool. But here's what's less discussed. The method relies on assumptions. It assumes that the amount of carbon-14 inches the atmosphere has always been constant. It assumes that the decay rate hasn't varied. It assumes that we can accurately calibrate the method against known samples. And here's the thing. We've had to revise those assumptions multiple times. When radiocarbon dating was first developed, the calibration was different from what we use now. Since then, we've discovered that carbon-14 levels in the atmosphere have fluctuated. We've discovered that different materials give different dates for the same event. We've had to make corrections for what's called the old wood problem, when an ancient structure is built from wood that was already hundreds of years old when it was used. The carbon dating of that wood gives an older date than the construction date of the structure. The conventional narrative presents this as scientists refining their methods, which is true. But there's a subtler issue. Each time we revise radiocarbon calibration, we're essentially acknowledging that our previous dates were wrong, sometimes significantly wrong. This doesn't mean radiocarbon dating is useless. It's still the best tool we have for determining dates within the range it covers. But it does mean there's fundamental uncertainty in how we date ancient objects. Potassium-argon dating works differently, but faces similar issues. It too relies on assumptions about initial conditions. It too has required recalibration as new evidence emerged. And it too introduces uncertainty into our dating of ancient geological events. Consider geological timescales. We determine the age of rock formations by looking at sedimentation rates. We measure how fast sediment accumulates in modern environments and assume that rate has always been constant. But here's what's interesting. Sedimentation rates vary dramatically depending on environmental conditions. They vary based on climate, water flow, everything. If past climate was different, and we know it was, then assuming current sedimentation rates applied to the past introduces significant error. What happens when you introduce small uncertainties into calculations that span thousands of years? The error compounds. A 5% uncertainty in dating might not sound dramatic, but applied across 10,000 years, it becomes 500 years of potential error. Applied across 20,000 years, it's 1,000 years. And if you're trying to establish when something occurred, being off by 1,000 years is significant. Here's what's rarely discussed. The academic literature contains numerous papers documenting these dating discrepancies. They're acknowledged. Scholars argue about how to resolve them. But to the public, to people learning history from textbooks, these methods are presented as settled. The dates are presented as facts. The uncertainty is hidden. This matters because it creates an illusion of certainty where genuine mystery exists. It makes it possible to dismiss as impossible any discovery that doesn't fit the established chronology. If a structure is found that shows sophisticated construction, but radiocarbon dating suggests it's older than humans are supposed to have been capable of such construction, the structure becomes anomalous rather than the chronology being questioned. What if the chronologies themselves are off? Not drastically, not by millions of years, but off by enough to accommodate some of the anomalies that currently seem impossible. What if civilizations did exist earlier than we think? What if Lemuria, if it existed, would have left artifacts dated to periods we currently don't believe humans were capable of sophisticated construction? The dating methods wouldn't disprove Lemuria. They would simply be giving us information about a past we haven't yet successfully interpreted. Approximately 12,800 years ago, something happened to Earth. We know it happened because the evidence is written in sediment layers worldwide, in ice cores from Antarctica and Greenland, in geological formations across continents, in the DNA of species that went extinct. Something massive occurred, and it changed everything. The most comprehensive explanation involves a cosmic impact. A comet or asteroid struck the Earth, or perhaps an airburst occurred in the atmosphere, an explosive event powerful enough to devastate without creating a visible crater. The evidence is specific. Iridium-enriched layers, at precisely that point in geological history. Iridium is rare on Earth's surface, but common in meteorites. Nanodiamonds in the same layers, diamonds formed under the extreme pressure of impact. Charcoal deposits worldwide suggesting massive fires, global ash in the atmosphere, creating a planetary dust veil that would have blocked out the sun for months or even years. What happened immediately after would have been nightmarish. With the sun blocked by dust, temperatures plummeted. Photosynthesis virtually halted. Plants died. The animals that depended on them starved. The animals that preyed on those animals starved. It was a cascading collapse of ecosystems. But the catastrophe didn't end after a few years of darkness. What followed was a period called the Younger Dryas, about 1,200 years of unstable climate. Conditions were cold. They fluctuated unpredictably. Agriculture would have been nearly impossible. Hunting and gathering would have become desperate struggles for survival. For a sophisticated civilization, this would have been extinction. Consider what a complex society requires: stable climate, predictable seasons, reliable agriculture, trade networks, infrastructure that depends on things working normally. All of these would have been destroyed. The institutions that maintain civilization would collapse. The knowledge that took generations to accumulate would be lost as people focused on immediate survival. But here's what's more significant. This wasn't the only catastrophe Earth has experienced. Our planet has a history of cycles. The concept of Milankovitch cycles developed by a Serbian mathematician named Milutin. Milankovitch describes how Earth's orbital variations create long-term climate patterns. These variations occur over tens of thousands of years. They're predictable, and they've caused significant climate shifts throughout Earth's history. Before the Younger Dryas impact, Earth was already in a period of climate transition. The last ice age had ended, sea levels were rising. But the rise wasn't gradual. There were periods of rapid change. Coastlines that had existed for millennia suddenly shifted. Land masses that had been accessible became submerged. The geography of entire regions changed. For a civilization based on maritime trade and settlement in coastal areas, exactly the kind of civilization that would have the knowledge to establish colonies across an ocean, this would have been catastrophic. Flooding events, tsunamis, changing currents and weather patterns. And finally, the impact itself. The catastrophe would have been total and complete. What's remarkable is how thoroughly a catastrophe like this could erase a civilization. If the civilization existed on a low-lying continent or vast plateau in the ocean, it would be submerged. If it existed in coastal areas, the flooding would destroy it. The survivors would scatter. They would carry with them whatever knowledge they could preserve, but most would be lost. The cities would be buried, the records would be destroyed, the centers of learning would be erased. Yet the survivors would remember. The trauma would be so profound that they would make the memory central to their culture. They would tell their children what had happened. They would encode the story in myth and religion. They would build civilizations in new locations, guided by survivors who remembered the old ways. And they would preserve, in fragments and in encoded forms, the knowledge that their predecessors had accumulated. This isn't speculation. This is how human culture actually works. Significant trauma becomes foundational to cultural identity. Survivor stories become founding myths. Knowledge gets encoded in ritual and religious practice. And if the source of that knowledge is forgotten, if the connection to the original civilization is lost, then over time, the knowledge becomes mythical. It seems impossible. It seems like fantasy, when actually, it's the preserved echo of a real civilization that no longer exists. Beneath the Indian Ocean lies a feature that geologists call the Mascarene Plateau. To understand its significance, you need to understand what the ocean floor is telling us. Most ocean floor is basalt dark volcanic rock. The crust beneath the ocean is fundamentally different from continental crust. Continental crust is lighter, less dense. Oceanic crust is heavier, older, and typically created at spreading ridges where new crust forms continuously. The Mascarene Plateau is different. Its composition suggests continental origin. Its structure suggests it wasn't always underwater. The explanation most consistent with the geological evidence is that it was once above sea level, that it sank, that something caused it to submerge beneath the ocean. Around this plateau lie scattered islands. The Seychelles are perhaps the most intriguing. They contain granite boulders, not volcanic rock, but granite. Granite forms from magma, cooling slowly underground, characteristic of continental crust. Granite is not what you'd expect to find on oceanic islands. Their presence suggests that the Seychelles aren't simply volcanic islands, but rather fragments of something larger, continental fragments, pieces of a landmass that was once continuous that broke apart and sank. Madagascar presents another puzzle. The island is home to species found nowhere else on Earth. Lemurs, in particular, are concentrated in Madagascar and in parts of India. The genetic distance between different lemur species and between lemurs and their nearest living relatives suggests they diverged when Madagascar and India were connected. Yet conventional geology struggles to explain how that connection could have existed without leaving more obvious traces. When oceanographers began drilling cores from the ocean floor, they discovered something that transforms our understanding. These cores contain the sedimentary record of Earth's climate history, and they reveal something crucial. Sea levels weren't always where they are now. They weren't always stable. After the last ice age, sea levels rose dramatically. Glaciers melted. Vast ice sheets that had covered large portions of North America and Europe turned to water that flowed into the oceans. But the rise wasn't smooth. The cores show periods of rapid change, acceleration, deceleration, reversals. The climate itself was unstable. During certain periods, sea levels would have been substantially lower than today, exposing continental shelves that are now underwater. During those periods, vast stretches of the ocean floor would have been habitable land. The concept of isostatic rebound is important here. Continents don't simply float on the ocean. They rest on the Earth's mantle. The weight of continental rock presses down on the mantle below. When conditions change, when the weight distribution shifts, when the thermal properties of the mantle change, continents rise or sink, it's not dramatically fast in human terms. But over tens of thousands of years, continental regions can move vertically by hundreds or even thousands of meters. What this means is that a landmass could have existed at sea level during periods of different climate and different mantle conditions. It could have persisted for thousands of years. It could have been ideal for human settlement and civilization building. And then, as climate changed and sea levels rose, it could have begun to sink, gradually at first. Then, more rapidly, as the catastrophe of the Younger Dryas impact accelerated the process. Imagine the Indian Ocean region in the period before 12,800 years ago. Imagine a massive plateau or collection of land masses where the ocean now is. Imagine that these lands were inhabited by a sophisticated maritime civilization. They would have developed extensive trade networks. They would have established colonies in favorable locations around the Indian Ocean. They would have preserved their knowledge carefully, because they would have recognized the fragility of existence in a maritime culture. One catastrophe could destroy everything. Then the catastrophe came. The impact, the climate chaos, the rising seas, the submersion of their homeland. The survivors would have been forced to flee to established colonies. They would have arrived carrying the memory of what was lost. The stories would have become sacred. The knowledge would have been preserved in whatever forms could survive. In religion, in architecture, in the founding stories of new civilizations. The geographical distribution of ancient civilizations, sudden appearance in Egypt, India, Mesopotamia, and other regions, becomes comprehensible if they were established by a diaspora of survivors. The similarities in knowledge and practice become comprehensible if they derived from a common source. The myths become comprehensible if they preserve memory of what was lost. What we call history is actually quite recent. History is the period for which we have written records. Everything before that is called prehistory, a strange term that essentially means the time before we started writing things down. But here's an assumption hidden in that terminology. We assume that everything important that happened before writing was invented is essentially unknowable. We assume that oral traditions are unreliable. We assume that if something isn't written down, it didn't really happen, or at least we can't trust reports about it. But consider, writing is a technology. It was invented relatively recently in human history. For thousands of years before writing existed, humans had sophisticated civilizations. They had complex languages. They had the ability to encode and transmit information. They had memory techniques that we've largely forgotten. They had the capacity to preserve knowledge through oral tradition, through artistic representation, through architectural encoding. What if a sophisticated maritime civilization existed on the lands of the Indian Ocean, lands now submerged before writing was invented in the Mediterranean or the Near East? What if this civilization developed astronomy, mathematics, medical knowledge, and architectural principles without recording them in written form? What if, when it was destroyed, the survivors carried that knowledge to new lands and new civilizations? The evidence for this is partly linguistic. Dravidian languages spoken in South India have peculiar similarities to languages spoken in Madagascar and Southeast Asia. The distribution of these languages makes sense if they derive from a common source, and if that source was in a region now underwater. Genetic analysis reveals population movements across the Indian Ocean region in ancient times, movements that suggest regular maritime contact across distances that seem extraordinary for primitive peoples. There are tantalizing hints in underwater archaeology. Submerged structures off the Indian coast, ancient ports now underwater, artifacts found at depths that would require them to have been placed there when sea levels were radically different from today. These discoveries are scattered and not yet comprehensively studied, but they paint a picture of ancient maritime activity in regions that conventional chronology doesn't adequately explain. The Indus Valley civilization itself presents a puzzle. When it emerged around 3300 BCE, it was already sophisticated. There's no archaeological record of its development. No trail showing how people gradually learned to build cities. No evidence of technological evolution. It's as if the knowledge was already present. As if the founders knew what they were doing because they had done it before, or because they had inherited the knowledge from somewhere else. Consider, what would survivors of a catastrophic event do? They wouldn't try to rebuild in the same location. That would be foolish. They would move to safer ground. They would establish new settlements in river valleys or coastal areas where agriculture was possible. They would carry with them the knowledge of how to organize settlements, how to build structures, how to trade and navigate. They would be refugees from a lost civilization, establishing new civilization in new lands. This would explain why advanced civilizations seem to appear suddenly and fully formed. It would explain why similar architectural and organizational principles appear across cultures separated by vast distances. It would explain why ancient knowledge in medicine, astronomy, and mathematics seems impossibly sophisticated for primitive societies. The conventional narrative treats each ancient civilization as essentially independent. But what if they weren't? What if the Indus Valley, Egypt, Mesopotamia, and other centers were actually daughter cultures of a single-parent civilization? What if they were established by survivors of Lemuria, each colony developing its own traditions while maintaining the foundational knowledge of the parent culture? This isn't to say there was no local development. Of course there was. Cultures evolved and diverged. But the base knowledge, the core understanding of mathematics, astronomy, and organization could have been inherited from a sophisticated predecessor, and that predecessor could have been Lemuria. Deep in the libraries of India lie texts that have survived thousands of years: the Vedas, the Puranas, the Ramayana, and Mahabharata. These aren't simple religious texts, they're vast, complex repositories of information. They contain mythology, yes, but they also contain detailed descriptions of geography, of astronomy, of civilization, and of events that happened in the distant past. For centuries, Western scholars dismissed them as purely mythological. But increasingly, scholars of Hindu and Vedic literature are recognizing that these texts are preserving actual historical information embedded within narrative structures. The Vedas describe something called the Four Ages, the Yugas. According to this cosmology, time moves in cycles. Each age, each yuga, has specific characteristics. The Satya Yuga was an age of truth and perfection. The Treta Yuga saw a decline. The Dvapara Yuga declined further. The current age, the Kali Yuga, is an age of degradation and darkness. But here's what's significant about this framework. It describes human civilization as cyclical. It acknowledges that previous ages existed, previous levels of development, implicitly, previous civilizations that reached heights and then fell. The Mahabharata and Ramayana contain descriptions that are remarkably specific. They describe cities and their locations. They describe trade routes. They describe the technology and capabilities of ancient peoples. Modern scholarship has begun to recognize that some of these descriptions correspond to real geographical locations and real historical events. Events that seemed mythical because we didn't have the archaeological evidence to confirm them, yet the texts described them with remarkable accuracy. The Tamil text, Silapatikaram, contains explicit references to Kumari Kandam. The Tamil literary tradition describes this as a vast continent or region that existed to the south and east of the current Indian peninsula. The text doesn't describe it vaguely. It mentions cities, trade routes, and cultural practices. It describes the catastrophe that destroyed it as a sudden submersion beneath the sea. It places this event in a historical context, suggesting that survivors migrated to other regions. The most compelling evidence for this tradition comes from archaeology. The underwater city of Dwarka, off the coast of Gujarat in India, was long known from Hindu texts. Krishna, the central figure in Hindu mythology, was described as the founder of Dwarka. It was known as a great city, a center of trade and civilization. For centuries, scholars treated this as myth. Then archaeologists found Dwarka, underwater, real structures, real artifacts. Confirmation that something described in ancient texts as having been destroyed and submerged by the sea actually was destroyed and submerged by the sea. This discovery is significant not because it proves that Krishna was a literal historical figure, but because it demonstrates that the ancient texts were preserving historical information. The texts described a real city. The texts remembered that it had been submerged. The texts contained enough accurate information that when archaeologists went looking, they found it. When you examine these texts, with the understanding that they might be preserving history rather than pure mythology, patterns emerge. The descriptions of advanced knowledge, the references to civilization existing in regions now underwater or inaccessible, the accounts of catastrophic events that destroyed what was. These aren't fantastical elements added for dramatic effect. They're preservation of information by people who recognized that their knowledge was fragile, that catastrophe could destroy it, that the only way to ensure it survived was to make it sacred, to encode it in stories and religious practices, to transmit it through generations as if it were divine truth. Consider the concept of transmitting knowledge through religious practice. A ritual performed in a specific way, with specific tools and specific verbal components. The knowledge is embedded in the ritual itself. As long as the ritual is performed, as long as it's treated as sacred and unchangeable, the knowledge is preserved. The person performing the ritual might not understand why they're doing it a certain way. They might not understand the scientific principles underlying the practice, but they're preserving those principles in encoded form. This is exactly what we see in ancient cultures worldwide, rituals and religious practices that encode practical knowledge. Astronomical knowledge embedded in temple orientations and sacred calendars. Medical knowledge embedded in ritual purification practices. Agricultural knowledge embedded in seasonal ceremonies. The knowledge isn't just information, it's preserved in action. It's impossible to forget, because forgetting would require actively stopping something that has become central to cultural identity. The ancient texts speak of knowledge brought from distant places, divine beings arriving to establish civilization, teachers and instructors arriving with advanced knowledge. If you approach these texts as preserving memory of a real diaspora, survivors from a destroyed civilization, arriving in new lands and establishing new societies, these descriptions become comprehensible. They're not describing supernatural events. They're describing the arrival of people with knowledge that exceeded what the local populations possessed. When you examine monuments and structures across the world, something peculiar becomes evident. They share mathematical and geometric principles, not similarities that could be coincidental, not the kind of patterns that might emerge from universal human preferences. Rather, specific mathematical relationships, specific geometric ratios, specific architectural principles. The pyramids in Egypt were constructed using principles of sacred geometry. The proportions are precise, the angles are specific, the orientations are astronomically aligned. But here's what's remarkable. If you travel to Mesoamerica and examine the pyramids there, you find similar principles. The angles are comparable. The mathematical relationships are alike. The astronomical alignments follow similar logic. In India, the temples, particularly those constructed to preserve Vedic knowledge, follow geometric principles that mirror Egyptian temples in many respects. The temple structures encode mathematical relationships. They orient toward celestial bodies. They incorporate proportions that reflect astronomical cycles. And the mathematics is the same. Not approximately similar, actually the same. The ancient world seemed to understand something about the golden ratio, the mathematical proportion that appears throughout nature and that possesses particular aesthetic and structural properties. This ratio appears in monuments worldwide, in the proportions of chambers and halls, in the relationships between different structural elements, in the sizing of architectural features. The consistency across cultures is striking. It's the kind of consistency that suggests transmission of knowledge rather than independent discovery. Consider astronomical alignment. Monuments across the world orient towards specific celestial points. The Great Pyramid aligns with Polaris. Egyptian temples align with specific stars. Mesoamerican structures align with celestial events like solstices. Aboriginal sites in Australia are oriented toward celestial bodies. It's as if all these cultures understood something about how to incorporate astronomical knowledge into architecture. As if they shared an understanding of why this was important. As if they inherited principles from a common source. What's even more interesting is the precision. The Giza pyramids have corners squared to within fractions of a degree. That requires specific surveying tools and knowledge of how to use them. It requires mathematical sophistication. It requires planning at a scale that demands organizational capability. We often attribute this to human ingenuity, and it is. But it also requires knowledge that seems to exceed what we think ancient cultures should have possessed. The placement of monuments relative to geographic features and celestial points suggests something extraordinary. It's as if the architects understood global geography. It's as if they could coordinate placement of structures across the world to maintain specific relationships. That seems impossible without some kind of advanced technology or communication system. But here's what's more likely. It suggests that the same architect engineers, or people trained in the same tradition, were responsible for multiple projects. That a diaspora of sophisticated builders spread out across the world, establishing monuments that reflected the same principles and the same knowledge. Sacred geometry isn't just mathematical. It's geometric, that is treated as sacred, that is encoded with significance, that is transmitted through religious and cultural practice as if it holds secrets. And here's what makes that relevant. If a civilization wanted to preserve advanced knowledge across a catastrophe, they would do exactly this. They would make geometric and mathematical principles sacred. They would embed them in temple construction so that the knowledge was preserved in stone. They would ensure that the knowledge survived by making it a central element of religious practice. The Fibonacci sequence, a mathematical pattern found throughout nature, appears in ancient architecture. The spiral, a sacred symbol in many cultures, is a Fibonacci spiral. The proportions that are considered beautiful in classical architecture reflect these mathematical relationships. It's as if ancient architects knew something about inherent patterns in nature that we've only recently rediscovered through modern mathematics. What makes this pattern of similarities across cultures so compelling isn't any single instance. It's the totality. It's the fact that you can't walk into an ancient temple, whether in Egypt, India, Peru, or Cambodia, without encountering the same geometric principles. It's the fact that modern analysis reveals mathematical relationships that seem too sophisticated to have been discovered independently by multiple cultures working in isolation. It's the pattern that suggests a common educational tradition, a shared body of knowledge, a transmission of principles from an advanced predecessor civilization. Ancient peoples were not simple people. They were sophisticated thinkers who faced a challenge we've largely forgotten. How do you preserve knowledge when you can't write it down? When writing hasn't been invented? Or when, for strategic reasons, you don't want knowledge written in ways that could be easily lost or destroyed? The answer they developed was elegant. Encode it in story. Myths aren't random. They follow patterns. The flood myths that appear in cultures worldwide, they follow consistent narrative structures. Someone is warned of a coming catastrophe. Animals are gathered. Water rises. The world is destroyed. Survivors repopulate the world. This isn't a pattern that emerges by chance. It's a pattern that suggests memory, actual experience preserved in narrative form. When you examine deluge myths across cultures, they contain specific details. Details about animal selection, details about preservation of plants, details about the method of survival. These aren't random plot elements, they're information. How would you preserve biological knowledge if you couldn't write down scientific descriptions? You'd encode it in the story of animals being saved during a flood. The knowledge is embedded in the narrative. Consider gods and divine beings. Across cultures, divine beings are described as bringing specific knowledge. A god of thunder that might encode information about electrical phenomena. A god of health that might preserve medical knowledge. A divine teacher that might represent a human instructor from an earlier civilization. What would seem like fantasy to someone who doesn't know the original context becomes transparent when you understand that the divine figure is a metaphor for knowledge transmission. The story of Prometheus bringing fire to humanity is often treated as pure mythology. But what if fire is a metaphor for technology? What if Prometheus represents an advanced civilization sharing knowledge with less advanced peoples? The narrative makes perfect sense that way. A benefactor arrives. Knowledge is transmitted. The transmission creates resistance and resentment from those who held power based on knowledge scarcity. The benefactor is punished. But the knowledge has been shared. Symbolic language allowed complex information to persist through generations of oral transmission without corruption. Unlike literal description, which would be corrupted by misremembering, symbolic narrative remains stable. The story is told the same way because it's sacred. The meaning is encoded in symbols that can be interpreted by those trained to understand them. Look at Taoist philosophy or Hindu cosmology. These contain profound metaphors about the nature of reality, the structure of the universe, and the relationship between observer and observed. When subjected to modern scientific interpretation, these metaphors encode actual insights into physics and consciousness. It's not that the ancients possessed quantum mechanics. It's that they possessed sophisticated observation of natural phenomena, and they encoded what they observed in metaphorical language that would be preserved precisely because it was sacred. Religious symbols appear across cultures and time periods with remarkable consistency. The cross, the spiral, the lotus, the serpent. These symbols appear in ancient Egypt, in India, in Mesoamerica, in indigenous cultures worldwide. The symbols are the same, not because humans all independently invented the same symbols. They're the same because they meant something important, because that meaning was deliberately preserved, because cultures transmitted these symbols as sacred, as containing significance. The ancient mystery schools, the esoteric traditions guarded by priesthoods in Egypt, in Greece, in India, preserved knowledge through symbolic initiation. Initiates learned to interpret symbols. They learned the language in which knowledge was encoded. This was an explicit recognition that knowledge could be preserved in symbolic form, that understanding the symbols gave access to understanding nature itself. What this suggests is that ancient peoples were perhaps more sophisticated in their approach to knowledge preservation than we give them credit for. They recognized that knowledge is fragile, that civilizations can be destroyed, that the only way to ensure knowledge survives is to make it sacred, to embed it in practice and symbol, to transmit it in forms that are unchanging, because they're religious rather than merely informational. If a civilization faced extinction, they would deliberately preserve knowledge in every form they could. Written records wouldn't be enough, they could burn. Oral traditions wouldn't be enough, they could be forgotten. But knowledge encoded in religious practice, in sacred geometry, in symbolic narrative, in ritual that could survive. That would be preserved by people whose primary goal wasn't understanding the knowledge but preserving their religion. The night sky tells stories. To someone trained to read it, the night sky is a calendar, a map, and a record of knowledge. Ancient peoples were trained to read it. They understood celestial mechanics in ways that seem impossible without sophisticated instruments. The precession of the equinoxes is a phenomenon that requires centuries of careful observation to detect. It's a slow wobble in Earth's axis. Over a period of approximately 26,000 years, that wobble creates a slow rotation in which star serves as the pole star. This is not casual observation. This requires systematic observation over centuries. It requires mathematical sophistication to describe. It requires understanding of celestial mechanics. Yet Hindu cosmology describes precession precisely. The Vedic texts contain descriptions of precession that match modern astronomical understanding. They calculated durations and patterns with remarkable accuracy. How did they know? The most obvious explanation is that they observed, that they maintained systematic records over centuries, that they developed mathematical frameworks to describe what they observed. But that requires the kind of astronomical tradition and institutional support that we typically attribute only to modern civilization. The Egyptians encoded astronomical knowledge in the design of temples. The Dendera temple contains representations of astronomical phenomena with precision that suggests direct observation rather than mythology. Similar precision appears in pyramids and other structures. The orientations weren't accidental. They weren't rough approximations. They were specific. They reflected knowledge of celestial mechanics. The Nabatean civilization possessed knowledge of stellar motion, the apparent drift of stars across the sky over time. This is not obvious observation. This requires comparing observations separated by many years, precisely measuring positions, and noticing tiny changes. It requires mathematical sophistication. Yet the Nabateans documented it. This knowledge wasn't officially rediscovered until the 18th century, but they had it. The Dresden Codex, a Mayan astronomical text, documents the cycle of Venus with extraordinary precision. The accuracy of these calculations suggests observation over centuries. It suggests mathematical frameworks for predicting celestial positions. It suggests that the Mayans weren't making lucky guesses, they understood something about the mechanics of planetary motion. Consider what knowledge of astronomy would have been useful for. Navigation is the primary application. If you're trading across oceans, if you're establishing maritime colonies, if you're relying on navigation to maintain trade networks, then astronomical knowledge is crucial. It's not luxury knowledge, it's survival knowledge. A maritime civilization would naturally develop sophisticated astronomy. They would maintain records. They would systematically improve their knowledge because their survival depended on accurate navigation. What becomes remarkable is that this astronomical knowledge appears in multiple cultures in similar forms. Not identical, there are differences in terminology and emphasis, but the core knowledge is the same. The mathematics is compatible. The observations are consistent. It's as if multiple cultures inherited from a common source, the framework for understanding the sky. There's a possibility that seems almost too significant to mention. What if ancient peoples understood more about the cosmic cycles than we do? What if they recognized patterns that we haven't yet identified? What if their emphasis on cyclical time, their understanding that civilizations rise and fall, that knowledge is gained and lost, that catastrophes repeat, was based on observation of longer cycles than we're currently comfortable acknowledging? The concept of precession describes a 26,000-year cycle. That cycle can be broken into 12 ages of approximately 2,160 years each. This division appears in numerous traditions: the zodiacal ages, the Hindu yugas, the Babylonian cosmology. Is it coincidence that cultures developed the same division? Or is it recognition of a pattern that's actually there in nature, a pattern that a sophisticated observational tradition would have detected? The Edwin Smith Papyrus is one of the oldest medical documents known. It dates to ancient Egypt, over 4,000 years ago. What's remarkable about it isn't just that it contains medical information, it's the specificity and sophistication of that information. It describes the circulatory system. It describes the heart and its function. It describes disease processes. It describes treatment approaches. It reads like a medical textbook, not mythology. In ancient Peru, archaeologists have found evidence of sophisticated surgical procedures. Trephination surgical opening of the skull was performed with success rates that would be respectable even by modern standards. These weren't experimental procedures. They were routine operations. The skulls show evidence of healing after surgery. The bone growth indicates survival of the patient. This was successful medical practice conducted thousands of years ago. How would a culture develop surgical capability without knowledge of anatomy, without understanding of disease processes, without knowledge of sterilization or anesthesia? The answer that fits the evidence is, they inherited it. They inherited the knowledge and the techniques from a predecessor civilization. They performed procedures without necessarily understanding all the underlying principles. The knowledge was transmitted as, this is how you do it, without necessarily transmission of the deeper understanding of why it works. The Indian medical tradition of Ayurveda contains descriptions of disease and treatment approaches that modern research has validated. It describes herbs and plants with specific healing properties. Modern pharmacological research has confirmed that many of these plants do contain active compounds with medical effects. It describes disease processes and diagnostic approaches. Some of these approaches seem almost impossibly sophisticated for a pre-scientific culture. The question that hasn't been adequately answered is, how did these cultures discover this knowledge? How did they identify which plants had medicinal properties? Trial and error would take centuries. Poisoning, side effects, adverse reactions, all would have been common as cultures experimented. Yet the Ayurvedic tradition doesn't read like centuries of trial and error. It reads like knowledge that was already understood, like a transmission of information from a source that already knew the answers. Ancient texts describe surgical anesthetics. They describe surgical procedures of remarkable complexity. They describe understanding of the nervous system, the circulatory system, and organ function. This knowledge seems impossible without systematic dissection and observation of the human body. Yet many ancient cultures had religious prohibitions against dissection. How would you develop such sophisticated medical knowledge without being able to observe directly? One possibility is that the knowledge was inherited before the religious prohibitions developed. That a sophisticated medical tradition was transmitted to cultures that then adopted religious frameworks that prevented further advancement. The knowledge would be preserved, passed down through ritual and tradition, but new knowledge wouldn't be generated because the practices necessary to develop it were prohibited. Another possibility is that some ancient cultures did practice systematic dissection and anatomy study, that we simply haven't found the evidence yet, or that the evidence has been overlooked because it contradicts assumptions we've made about ancient capabilities. What's undeniable is that medical knowledge in ancient cultures exceeds what we'd expect from independent discovery. The consistency of knowledge across cultures suggests transmission. The specificity and sophistication suggest that the source was a civilization with advanced scientific understanding. The preservation through religious and cultural practice suggests that the knowledge was made sacred, that it was deliberately protected and transmitted because its value was recognized. A science isn't just isolated discoveries. It's a framework for understanding natural phenomena. It's methodology. It's the ability to conduct systematic investigation and refine understanding based on evidence. It's reproducibility. It's the progression from observation to hypothesis, to testing, to refined understanding. The presence of isolated, sophisticated knowledge in ancient cultures isn't as significant as the pattern of systematic knowledge. What suggests that Lemuria possessed science, actual science, is that the knowledge appears as a coherent framework. Astronomy connects to mathematics. Mathematics informs architecture. Architecture preserves astronomical knowledge. Medicine connects to understanding of the body. Understanding of the body informs agriculture and nutrition. Everything connects. In the Hindu Vedic tradition, there are descriptions of concepts that seem modern in their sophistication. Descriptions of atomic theory, descriptions of electromagnetic phenomena, descriptions of consciousness and observation affecting physical reality. These concepts appear in sacred texts written thousands of years ago. They're encoded in philosophical frameworks. They read like attempts to describe physical phenomena that the author observed or understood, but didn't have modern terminology to express. In ancient Egyptian texts, there are descriptions of temples and structures that might have served scientific purposes beyond religious function. The precision of certain architectural features suggests they might have served as instruments, tools, for observation or measurement. The orientation and geometry might have encoded understanding of physical principles. It's speculative, but worth considering. What if some ancient temples were actually scientific observatories or experimental facilities? The work of researchers examining ancient texts from the perspective of systems thinking reveals patterns. The knowledge isn't random, it's interconnected. It suggests a civilization that had developed frameworks for understanding natural phenomena. Not complete science, as we understand it, not with modern instrumentation and methodology, but systematic observation, logical inference, and attempted explanation of natural phenomena. What would destroy such a civilization? Actually, catastrophe wouldn't just destroy it, it would make it impossible to rebuild. A scientific civilization is dependent on sophisticated infrastructure. Libraries, observation instruments, facilities for experimentation, population density sufficient to support specialists. All of these would be destroyed by catastrophe. The survivors would have knowledge, they would carry it in their minds and in encoded form, but the infrastructure necessary to continue developing science would be lost. This explains why, after catastrophe, we'd see preservation of knowledge in mythological and religious forms. Survivors wouldn't be able to maintain scientific practice, they'd be focused on survival, but they would make sure the knowledge was preserved. They would embed it in ritual and religion. They would make it sacred. And they would transmit it to whatever descendants survived to the next civilizations they established. The pattern we see in history is periods of apparent sophistication in isolated domains, preserved through religious practice, with no evidence of progression or development. Egypt developed certain technologies and architectural capabilities and maintained them for millennia without substantial innovation. The Indus Valley civilization appeared sophisticated and then dispersed without obvious development. These civilizations preserved knowledge. They didn't generate new knowledge. They transmitted what they had. This makes perfect sense if they were inheriting knowledge from a sophisticated predecessor that had been destroyed. They would know some things with remarkable precision. But they wouldn't be able to understand the underlying principles, or build upon the knowledge to create new discoveries. They would be custodians of inherited knowledge, rather than practitioners of science. When a civilization is destroyed, the survivors don't disappear. They flee, they scatter, they carry with them whatever knowledge they can preserve and whatever physical possessions they can transport. If a maritime civilization in the Indian Ocean was destroyed, where would the survivors go? The geography of the Indian Ocean provides clues. There are natural refuge regions, places where people could establish settlements, where agriculture was possible, where trade networks could be re-established. The coasts of India, the river valleys, Southeast Asia, Egypt accessible through known maritime routes, East Africa. These regions would have attracted survivors not randomly but strategically. People would establish colonies in places where they could survive and rebuild. The archaeological evidence shows something remarkable happening in the period after 12,000 years ago. Sophisticated civilizations appear in multiple regions roughly simultaneously. It's as if populations moved into these regions, bringing knowledge with them. It's as if they established cities and culture systems, as if they were replicas of something they had known before. The Indus Valley civilization emerges around 3,300 BCE. Egypt's first dynasty begins around 3,100 BCE. The civilization in Mesopotamia develops around the same period. These aren't sequential, one leading to another through cultural contact. They're concurrent. They're as if multiple groups of survivors arrived at different locations at approximately the same time, each establishing a civilization that reflected the knowledge they carried. Linguistic evidence supports this dispersal model. Dravidian languages in South India show connections to languages in Southeast Asia and Madagascar. The distribution doesn't make sense if these were isolated language families developing independently. It makes sense if they derive from a common source language that dispersed when a maritime population scattered. Genetic studies reveal population movements. DNA analysis shows admixture patterns, the mixing of different populations that suggest migrations. Populations arriving from elsewhere and mixing with established groups. The timing of these migrations, when calculated from genetic data, aligns with the period of catastrophe and the emergence of sophisticated civilizations. The distribution of ancient civilizations follows a logical pattern for a maritime diaspora. They're concentrated around the Indian Ocean and in regions accessible from it. Egypt provides access to the Mediterranean and beyond. The Indus Valley is positioned for trade with Southeast Asia. Mesopotamia is positioned between Egypt and the Indus Valley. Southeast Asian civilizations provide access to maritime trade networks extending through the Pacific. A maritime civilization would naturally establish colonies in strategic locations, places where trade networks could be maintained, places where resources existed, places that could be defended and made self-sufficient. The survivors of Lemuria would have done exactly this. They would have identified locations where civilization could be re-established. They would have sent groups of survivors, perhaps with remaining ships and resources, to establish new settlements. These settlers wouldn't be arriving in empty lands. There were already populations in most of these regions. But the settlers would have arrived with knowledge, with organizational capability, with resources. They would have established cities and trade networks. They would have married into existing populations. Within a few generations, the settlers would be partially assimilated. But the knowledge would have been transmitted to the local populations. The cities would have been established. The trade networks would have been created. What we call the emergence of civilization in these regions might actually be the establishment of civilization by newcomers. Refugees from Lemuria arriving with knowledge and resources, establishing settlements that quickly became dominant cultural centers. Local populations would have been incorporated into these emerging civilizations. The settlers would have become the elite, the ones who possessed knowledge and organized the rest. This would explain the sudden appearance of sophistication. It would explain the similarities across regions. It would explain why certain practices and knowledge appear in multiple civilizations. It would explain the founding myths that speak of divine beings arriving from distant lands to establish civilization. The refugees wouldn't have all gone to the same place. Some groups might have gone to Egypt, others to India, others to Southeast Asia. Some might have moved toward the Mediterranean. Some might have gone toward East Africa. The dispersal would have been driven by knowledge of existing trade networks, by connections to established settlements, by strategic calculation about where civilization could be rebuilt. Within a few generations, contact might have been lost between the scattered groups. Each group would be focused on survival and rebuilding, but the knowledge would have been preserved in each location. The architectural principles would be maintained because the cities were being built using remembered designs. The astronomical knowledge would be maintained in temple orientations and sacred practices. The medical knowledge would be preserved in ritual and practice. What we see in history is the result. Separate civilizations that would gradually develop distinct identities while maintaining core knowledge inherited from the common source. Over centuries, the connection to the original source would be forgotten. The knowledge would become mythological, attributed to gods and divine beings, rather than remembered as having been transmitted by human ancestors. The Indus Valley Civilization is one of history's great mysteries. It emerged apparently fully formed around 3,300 BCE in the river valleys of what is now Pakistan and northwestern India. It covered an area larger than Egypt or Mesopotamia. It contained cities with sophisticated urban planning, streets laid out in grids, buildings constructed with standardized bricks, sewage systems that would be impressive by modern standards. What's remarkable is that there's no obvious development leading up to it. Earlier settlements in the region show nothing approaching this sophistication. Then suddenly, the Indus Valley Civilization exists. It's as if the knowledge for creating such cities was brought from elsewhere, as if the founders knew exactly what they were doing because they had done it before. The civilization is distinctly maritime in character. There's extensive evidence of trade networks. Seals recovered from Indus Valley sites have been found as far away as Mesopotamia and the Persian Gulf. The artifacts suggest organized trade. The cities are positioned on rivers, but with knowledge of maritime trade. The layout suggests familiarity with port operations and maritime commerce. This is a civilization built by people who understood the sea, people for whom maritime trade was fundamental to their way of existing. The Indus script, the writing system used in the civilization, has never been definitively deciphered, but it shows similarities to script systems in other regions. Whether it's connected to other writing systems is debated, but the possibility exists. What's interesting is that if it is connected to scripts in other regions, it would suggest transmission of writing technology from a common source. Writing is not something that emerges independently very often. Usually, it's borrowed and adapted from elsewhere. The civilization's apparent lack of military focus is notable. Excavations reveal few weapons. There's no evidence of fortifications or large-scale warfare. The organization seems oriented toward trade and cooperation, rather than conflict and conquest. This suggests a civilization that felt relatively secure, that didn't expect to be attacked. Or perhaps a civilization that was still relatively new, where the survivors who founded it were still numerous enough to maintain control without needing military infrastructure. The Indus Valley Civilization's decline around 1900 BCE is instructive. The civilization didn't gradually fade. It appears to have been disrupted by climate change and flooding. The river system destabilized. Water availability became unpredictable. For a civilization entirely dependent on river agriculture and irrigation systems, this was catastrophic. The population dispersed. People migrated to other regions, particularly eastward to the Ganges Valley. This dispersal is significant. The people who left the Indus Valley didn't disappear. They established new settlements in the east. They mixed with existing populations. They transmitted the knowledge they possessed. The language that would become Sanskrit emerged from this encounter. The religious traditions that would become Hinduism emerged from a synthesis of Indus Valley civilization and the cultures of the peoples they encountered. The Vedas, the sacred texts of Hinduism, preserve hints of this history. They speak of migrations. They speak of cities and civilizations. They preserve knowledge that appears to derive from the Indus Valley civilization. The astronomical knowledge in the Vedas, the mathematical understanding, the architectural principles, these align with what we know of Indus Valley culture. The legacy of the Indus Valley civilization persists in South Asia to the present day. The mathematics of the region, the use of zero, the development of the decimal system, the advances in geometry, these emerge from the cultural tradition inherited from the Indus Valley. It's as if the knowledge base established in the Indus Valley provided the foundation for subsequent developments in Indian mathematics and science. If the Indus Valley civilization was indeed established by survivors of Lemuria, bringing knowledge and organizational capability, then its rapid emergence, its sophistication, its maritime focus, and its specific knowledge base all make sense. The survivors arrived in a location with favorable geography. They established a city system based on remembered designs. They organized trade networks based on remembered routes and practices. They transmitted knowledge through the local population, through trade and cultural assimilation. The civilization's vulnerability to climate change, its dependence on specific river systems, makes sense if it was transplanted from a maritime base to an inland location. A maritime civilization would naturally be vulnerable in a river valley if the rivers became unstable. The dispersion would be natural. The survivors would flee to other regions. The knowledge would be transmitted as people moved. The persistence of Lemurian knowledge in the Indian tradition is perhaps most obvious in the mathematical and astronomical sophistication that emerges and develops in Indian civilization. If India inherited the knowledge base of Lemuria, it would explain why Indian mathematics and astronomy are among the most advanced in the pre-modern world. Egypt presents another puzzle. The civilization that built the pyramids didn't evolve from simpler cultures in the Nile Valley. It appeared around 3100 BCE, in the First Dynasty, we encounter Egypt as a fully organized nation-state. There is writing, there is a bureaucracy, there is architectural knowledge, there is artistic sophistication, there is religious organization, there is everything that characterizes a developed civilization. But there are no clear predecessors. The conventional explanation is that Egyptian culture developed gradually from simpler beginnings that we haven't found in the archaeological record. But there's another explanation that fits the evidence at least as well. Egypt was established by survivors of Lemuria, arriving with knowledge and organizational systems already intact. Egypt's focus on maritime trade supports this interpretation. The early dynasties engaged in extensive trade across the Mediterranean and beyond. The civilization understood navigation and maritime commerce. This knowledge wouldn't be unusual for a culture that had inherited maritime traditions from a predecessor civilization. But it's remarkable for a culture that developed in isolation in the Nile Valley, far from the open ocean. The pyramid texts, among Egypt's oldest religious documents, contain references that are difficult to interpret. They speak of journeys from distant lands. They reference origins in places not easily identified on a map. Some scholars have suggested they preserve memory of an origin continent or civilization. The language is mythological, but what if the mythology is preserving historical memory? The astronomical knowledge encoded in the pyramids and temples exceeds what we'd expect from a culture developing independently. The Dendera temple contains a representation of the zodiac with extraordinary precision. The alignment of temples and pyramids with celestial bodies shows knowledge that would require centuries of systematic observation. This knowledge would be natural for a maritime civilization accustomed to using the stars for navigation, but it seems to exceed what an inland river valley civilization would develop independently. The connection between Egyptian and Indian religions is intriguing. Both developed monotheistic phases. Both incorporated similar symbols. Both demonstrated similar cosmological understanding. Both emphasized the relationship between human order and cosmic order. Are these similarities due to contact and trade, or do they reflect inheritance from a common source, Lemuria? Africa itself presents intriguing possibilities. The southeastern coast of Africa, the Indian Ocean islands, the East African coast. These regions show evidence of ancient maritime activity. Archaeological evidence suggests trade and contact across the Indian Ocean in ancient times. Madagascar, geographically closer to Africa than to Asia, is populated by peoples whose language and genetics suggest origins in Southeast Asia. How did Southeast Asian peoples arrive in Madagascar? The answer is, by boat, maritime contact across the Indian Ocean. The evidence for ancient Indian Ocean trade is substantial. Ports and trading stations have been identified. Trade goods items from one culture found in another document, maritime commerce. What's less discussed is how extensive and sophisticated this maritime network must have been. To maintain regular trade, you need knowledge of routes, seasons, navigation capabilities, and infrastructure at both ends. If survivors of Lemuria were established in Egypt, positioned at the gateway to the Mediterranean, they would naturally seek to expand trade networks. They would seek to maintain maritime contact with other diaspora settlements. They would establish trading relationships with African populations. They would build ports and facilitate commerce. Egypt's remarkable preservation of knowledge over millennia suggests a civilization that was deliberately maintaining traditions. The religious continuity, the artistic consistency, the the preservation of ancient texts and practices. This is a culture that valued preserving the past. What if part of what was preserved was knowledge inherited from Lemuria? What if Egypt saw itself as the guardian of that knowledge? The role Egypt played in transmitting knowledge to later civilizations, to Greeks, to Romans, to Islamic scholars, was crucial. The Greeks and Romans viewed Egypt as ancient and wise. They studied Egyptian knowledge. The Islamic scholars preserved Egyptian and Greek knowledge through the Dark Ages of Europe. If Egypt was preserving knowledge inherited from Lemuria, it was serving as a crucial transmission point through which that knowledge entered the Western tradition. When civilizations speak of golden ages, times of perfection and peace, they're often preserving memory of something. The Hindu concept of the Satya Yuga, the Golden Age. The Greek concept of the Age of Gold under Kronos. The notion that time moves from perfection toward degradation. What if these aren't arbitrary mythological concepts, but preservation of memory? Memory of a time before catastrophe, when civilization had reached heights, when peace prevailed, when knowledge flourished. And then, it all ended. 12,800 years ago, precisely datable from geological evidence, something catastrophic occurred. The evidence is overwhelming. Sediment layers from that exact period, worldwide, contain indicators of impact. Iridium from space dust. Nanodiamonds formed under extreme pressure. Charcoal from massive fires. Shocked quartz crystalline structures altered by intense heat and pressure. The signature of a cosmic impact. The impact itself would have been devastating. If a comet or asteroid struck the Earth, the immediate effects would be catastrophic. Massive explosions, earthquakes triggered by impact, tsunamis in oceans and seas. For a maritime civilization, a tsunami would be catastrophic beyond measure. Coastal cities would be obliterated, ships would be destroyed. The infrastructure of maritime trade would collapse. But the impact itself wasn't the only catastrophe. What followed was equally devastating. The impact ejected dust and debris into the atmosphere. Soot from fires joined the dust. Within weeks, the sun would have been substantially obscured. Within months, the obstruction would have created conditions approaching permanent darkness. Temperatures plummeted. What was called the Younger Dryas, a period of cold climate, began. For approximately 1,200 years, the climate was unstable and cold. For a civilization dependent on agriculture, this would have been extinction. Crops wouldn't grow, animals would starve, hunger would drive populations to desperation. For a maritime civilization, the disruption of trade would have been similarly catastrophic. The stable conditions necessary for maritime commerce would be lost. Ocean currents would be disrupted. Weather patterns would be chaotic and dangerous. For the low-lying continents or plateaus where Lemuria might have existed, the disaster would have been compounded. The impact could have triggered sea level changes. The 1,200 years of climate instability would have further disrupted ocean systems. The combination would have been unrelenting. Survival would require abandonment of the original homeland. The refugees would need to flee to locations where agriculture was still possible, where the disruption was less severe, where they could attempt to rebuild. Most would have died. This is the terrible reality of catastrophe. Most survivors perish in the aftermath. Disease follows disruption. Starvation follows the failure of food systems. Violence erupts as surviving groups compete for remaining resources. The trauma would be absolute and generational. Those who survived would carry the psychological weight of having witnessed the complete destruction of their world. Yet some would survive. Those with maritime knowledge would have better chances. They could navigate to locations with fewer survivors, where resources were more available. Those with agricultural knowledge would have better chances. They could establish new settlements in favorable locations. Those with social knowledge would have better chances. They could organize surviving populations, establish hierarchy, and create structures for collective action. The surviving elite of Lemuria would have carried knowledge, in their minds, in their memories, in whatever written records they could preserve. They would have understood what had happened. They would have recognized that their civilization had been destroyed. They would have begun to think about preservation, about how to ensure that the knowledge accumulated over generations wouldn't be lost. Survivors of catastrophe understand something crucial. Knowledge is fragile. You can destroy knowledge in moments that took generations to accumulate. A library burns. A tradition is forgotten. A skill dies with those who possessed it. If the survivors of Lemuria possessed sophisticated knowledge in mathematics, astronomy, medicine, engineering, they would have recognized the necessity of preservation. They would have understood that written records could be lost, that libraries could burn, that papyrus decays, and clay tablets shatter, so they would have employed multiple preservation strategies. Some knowledge would be encoded in written form, but more importantly, it would be encoded in forms that would survive regardless of physical destruction. Religious practice is extremely conservative. Once a ritual is established as sacred, it's performed the same way for centuries, for millennia. The knowledge embedded in the ritual is preserved precisely because the ritual is sacred and unchanging. Medical practices, if made sacred, will be transmitted unchanged through generations. Architectural principles, if encoded in temple designs that are sacred, will be preserved because the temples will be rebuilt according to traditional designs. Mythology provides another preservation medium. A story told and retold remains relatively stable through oral transmission because the narrative itself is valued. The details that matter are preserved because they're part of the story. Details about technology or knowledge, if embedded in mythological narrative, will survive with remarkable fidelity. The survivors of Lemuria would have deliberately made certain knowledge sacred. They would have established priesthoods to preserve and transmit that knowledge. They would have created mystery schools where esoteric knowledge was guarded and transmitted to initiates. They would have encoded knowledge in architecture so that buildings themselves would preserve information. They would have created ritual practices that encoded practical knowledge. This strategy explains what we observe in ancient civilizations. Knowledge that seems anomalously advanced, appearing in religious and ritual contexts, architectural principles that exceed what should have been possible, medical and astronomical knowledge preserved in sacred traditions, symbols that encode meaning and are transmitted unchanged across generations. The survivors would also have recognized that they needed to establish new civilization centers. They couldn't rebuild in the same location. That would be foolish. They would need to disperse, to establish colonies in multiple locations. Each colony would preserve knowledge and maintain trade connections if possible. Each would develop somewhat independently, but would maintain core knowledge inherited from the parent culture. This explains the pattern of emergence of sophisticated civilizations in multiple locations. They weren't independent developments. They were colonies or offspring civilizations of a destroyed parent. They inherited knowledge. They inherited organizational structures. They inherited the understanding of how to build cities and organize complex societies. They would develop distinctive characteristics over time, but their foundation was knowledge and structure inherited from Lemuria. The survivors would have understood something else, that their immediate descendants might lose the technical capability to rebuild civilization to its former level. Infrastructure would be lost. Population would be reduced. Resources would be scarce. The specialized knowledge necessary for advanced technology would be scarce. So they would focus on preserving principles and methodology rather than specifications. They would ensure that the fundamental understanding of mathematics, astronomy, and organization would be preserved, even if the ability to build advanced technology was temporarily lost. The ocean floor of the Indian Ocean covers millions of square kilometers. If Lemuria existed as a low-lying continent or complex of elevated plateaus, its ruins would be scattered across an enormous area. It would be difficult to find. It would be challenging to excavate. It would be impossible to comprehensively map. And yet, intriguing discoveries continue to emerge. Dwarka, off the coast of Gujarat, was found underwater. It matches descriptions in Hindu texts. It's a real city that was submerged. The archaeological evidence is substantial. It demonstrates that ancient maritime civilizations did exist, that advanced urban structures were built in coastal areas, that sea level rise did submerge settlements. It demonstrates that what ancient texts describe as sunken cities isn't fantasy, it's historical fact. Other underwater structures have been found and are being investigated. The Yonaguni Formation off Japan, whether natural or artificial, its geometric regularity demands explanation. Structures off Peru and Cuba, that show geometric organization. These discoveries are scattered. They're not yet comprehensively studied or authenticated, but they're consistent with the hypothesis that ancient maritime civilizations existed and were submerged. The challenge of underwater archaeology is substantial. Structures are covered in sediment. They're colonized by marine life. They're in harsh environments, deep, cold, high pressure. Recovery and documentation are technically difficult. Cost is substantial. Systematic exploration has barely begun. We've mapped more of the moon's surface than we've mapped the Earth's ocean floor. Sonar imaging is improving. Submersible technology is advancing. Underwater robotics are becoming more sophisticated. As these tools improve, more discoveries will be made. Some will be natural formations. Some will be artifacts of human activity. Some will be ambiguous. But the more we look, the more we'll discover. What's significant is not whether any single underwater structure is definitively proof of Lemuria. What's significant is the pattern. Underwater settlements exist. Ancient peoples did live in coastal regions now submerged. Maritime trade was more extensive in ancient times than conventional history acknowledges. The pieces fit together. They create a picture of a world more connected, more sophisticated, and more vulnerable to catastrophe than we typically imagined. Biological and geological processes actively destroy evidence. Wood decays, metal corrodes, stone erodes, sediment accumulates, earthquakes disrupt structures. Over thousands of years, the evidence of human habitation deteriorates. If Lemuria existed, substantial physical evidence would remain. But it would be challenging to find, challenging to recognize, and challenging to authenticate. The absence of overwhelming evidence doesn't mean Lemuria didn't exist. It means that if it did exist, we haven't yet found the evidence, or we haven't recognized what we found, or the evidence is inaccessible beneath layers of sediment and ocean water. The hypothesis isn't disproven by the absence of evidence. It's supported by the pattern of anomalies that would make sense if Lemuria existed. The ocean floor is a frontier. We're only beginning to explore it. The discoveries we'll make over the coming decades may rewrite our understanding of ancient history. The ruins we find might be from Lemuria. They might be from other civilizations we haven't yet imagined. But the ocean floor will tell us something. And that knowledge will challenge our current understanding. Walk into the Great Pyramid of Giza, and you enter a space designed with extraordinary mathematical precision. The angles are specific. The proportions are calculated. The measurements relate to one another through geometric principles. The orientation aligns with celestial north. The dimensions encode information about the Earth itself. Nothing about this structure is accidental. Travel to Mesoamerica and enter a pyramid there. You find similar principles, similar angles, similar integration of astronomical alignment with architectural design, similar mathematical relationships between components. You find that the people who built this structure understood similar principles to the people who built the pyramid in Egypt. The similarities aren't superficial. They're not the kind of parallels that emerge from universal human preferences for certain shapes. They're specific mathematical relationships. When analyzed, they reveal an underlying commonality, as if people in both locations inherited knowledge from a common source, as if they were taught to build in similar ways. In India, temple construction follows principles that align with Egyptian temples, in the proportions, in the orientations, in the astronomical alignments, in the geometric integration. It's as if the knowledge of how to construct temples, how to encode astronomical information in architecture, how to use specific proportions, was transmitted from a common source to multiple locations. The precision required for this level of similarity is remarkable. The Great Pyramid has corners squared to within fractions of a degree. That requires knowledge of how to create right angles. It requires understanding of geometry. It requires tools to measure angles precisely. It requires planning at a scale and precision that demands organizational sophistication. We don't have evidence that Egyptian culture developed such knowledge from simpler beginnings. It appears fully formed. If we accept that such knowledge might be transmitted rather than independently developed, then the architectural similarities across cultures become comprehensible. They reflect a shared educational tradition, a shared body of knowledge, a transmission of architectural and mathematical principles from a culture that had already developed them. The placement of monuments relative to geographic features and celestial points is noteworthy. As if architects understood the geography of the world, as if they could coordinate placement of structures across continents to maintain specific relationships. That suggests either advanced communication and coordination, or more likely, that the same architects or people trained in the same tradition were responsible for multiple projects. Sacred geometry is the name given to geometric and mathematical principles treated as sacred. These appear in temple design, in spiritual art, in ritual spaces across cultures. The golden ratio, a mathematical proportion found throughout nature and considered aesthetically pleasing, appears in ancient architecture worldwide. The Fibonacci spiral, a mathematical pattern, appears as a sacred symbol in multiple cultures. The use of specific angles appears across cultures. The sacred geometry of Mesoamerica involves angles and proportions that appear in Egyptian temples. The temple designs in India reflect similar understanding. It's not coincidence, it's transmission. It's evidence that architects understood principles that transcended their local cultures, that they had inherited knowledge from a predecessor civilization. What we're seeing in ancient monuments is the preservation of knowledge in stone. Architectural knowledge, mathematical knowledge, astronomical knowledge, engineering knowledge, all preserved in structures, all maintained because the structures themselves are sacred. They're rebuilt generation after generation. They're studied and revered. The knowledge embedded in them is preserved precisely because people recognize its value, even when they don't fully understand its meaning. The same symbols appear in cultures separated by oceans and centuries. The cross, the spiral, the lotus, the serpent, the geometric patterns. These aren't random symbols. They're not the inevitable products of human creativity. They're specific symbols appearing in specific forms across cultures that had no documented contact. The symbols appear most frequently in religious and spiritual contexts. They're treated as sacred. They're incorporated into temples and religious art. They're part of ritual. This is significant. Symbols that have religious significance are transmitted unchanged. They're treated as sacred and inviolable. If a symbol is sacred, it will be transmitted the same way across generations. What if these symbols encode meaning? What if they're a language? Not a language of words, but a language of meaning. If ancient peoples developed a symbolic language to encode knowledge, and if that language was made sacred, then it would be transmitted unchanged. It would appear in multiple cultures if those cultures inherited the knowledge from a common source. The cross, for instance, appears in cultures worldwide. In Egypt, in Mesoamerica, in India, in Aboriginal cultures in Australia. The cross represents something. In some cultures, it represents the cardinal directions. In others, it has astronomical significance. In others, it represents the intersection of material and spiritual. What if it represents all of these? What if it's a multivalent symbol, encoding different meanings for different interpretations, but with a common underlying significance? Gods and divine beings across cultures perform similar functions. They bring knowledge, they establish civilization, they teach humans. They're described with similar attributes. They're often associated with specific natural phenomena or knowledge domains. The god of agriculture, the god of the sea, the god of knowledge. What if these divine beings represent the preservation of memory of specific types of knowledge? What if a divine being is how a culture represents the transmission of specialized knowledge from a predecessor? In Hindu mythology, gods arrive from distant lands and establish civilization. In Egyptian mythology, divine beings establish the civilization and rule it. In Mesoamerican traditions, divine beings arrive and teach knowledge. The pattern repeats. It's as if each culture remembered the arrival of people with superior knowledge and encoded that memory in the form of divine beings or gods. A technologically advanced civilization would appear godlike to a less advanced population. Advanced knowledge would seem like magic. Advanced tools would seem like manifestations of divine power. If survivors of Lemuria arrived in new lands with superior knowledge and tools, they might be perceived as divine. That perception, encoded in mythology, would be transmitted through generations as the memory of gods establishing civilization. Religious symbols might encode memory of technology. A symbol of radiation-like emanations might represent a technology for energy transmission. A symbol of a chariot might represent a technological vehicle. A symbol of a device might represent tools or instruments. If technology was lost, but memory of it was preserved in symbolic form, made sacred, transmitted unchanged, then we'd find these symbols in ancient cultures. The careful treatment of certain symbols in mystery schools suggests that they carry meaning beyond surface interpretation. Initiates are taught to interpret symbols, to recognize their layered meanings. This suggests conscious encoding of information in symbolic form. It suggests that knowledge can be preserved in symbol if the symbol is treated as sacred and transmitted unchanged. Certain populations have historically produced disproportionate numbers of philosophers, mathematicians, scientists, and cultural innovators. India produced some of the world's greatest mathematicians. Egypt preserved and systematized knowledge from multiple sources. The Islamic world preserved Greek and Indian knowledge through periods when it was lost in Europe. Southeast Asian cultures developed sophisticated understanding of navigation and maritime trade. Is it coincidence that these regions, the regions that would have been diaspora centers of Lemuria, have been sources of intellectual and cultural achievement? Or does it reflect inheritance of knowledge and intellectual traditions from a sophisticated predecessor civilization? The Vedic tradition in India preserves sophisticated philosophical and mathematical thinking. The concepts of zero, of infinity, of abstract mathematics, these emerge from Indian mathematical tradition. The understanding of logic and epistemology in Hindu philosophy seems to reflect a tradition of systematic thinking. What if this represents inheritance of intellectual traditions from Lemuria? Populations with historical connections to maritime cultures display distinctive cognitive skills, navigation abilities that seem innate, mathematical facility that appears to exceed what they were formerly taught, organizational sophistication. These might reflect inheritance not just of knowledge but of ways of thinking, of intellectual traditions, of educational practices. The concept of cultural inheritance, how knowledge, values, and ways of thinking persist in populations across generations, is legitimate. It's how human culture works. What's transmitted is not just explicit knowledge but implicit knowledge, ways of thinking, problem-solving approaches, intellectual values. If a civilization had developed sophisticated ways of thinking, and if survivors transmitted those ways of thinking to successor populations, then we'd see persistent patterns of achievement in those populations. This isn't to say that any population is inherently superior. It's to say that intellectual traditions can persist, that populations can inherit not just genes but ways of thinking. That cultural inheritance is as real as genetic inheritance. If certain populations are descendants of survivors from Lemuria, they might carry inherited intellectual traditions, ways of approaching problems, values regarding knowledge and learning, orientations towards systematic thinking. The greatest achievement of a civilization isn't the knowledge it generates that can be lost. It's the people it produces, not genetically, but culturally. The people who are trained to think in certain ways, who value knowledge, who approach problems systematically. Those people and their descendants and their cultural traditions persist across catastrophe. They create new knowledge. They build new civilizations. They preserve the possibility of human achievement. If Lemuria existed, its greatest legacy wouldn't be architectural ruins or written records. It would be the people who survived, the traditions they transmitted, the ways of thinking they passed to their descendants, the intellectual values they instilled. Those persist to the present day in the cultures that descended from diaspora settlements. To understand human potential, to recognize what humans are capable of achieving, we need to understand that capability isn't new, that it's not unique to modern civilization, that humans have always been capable of sophisticated thinking, systematic investigation, and cultural achievement, and that those capabilities, once developed in a civilization, can be preserved and transmitted even through catastrophe. When you assemble the pieces, the geology, the archaeology, the texts, the genetics, the linguistic evidence, the architectural patterns, the symbolic connections, a picture emerges. Not a complete picture, not a definitive proof, but a coherent narrative that accounts for more observations than conventional history does. The narrative is this. Lemuria was a sophisticated maritime civilization that existed in the Indian Ocean region, flourishing during periods when sea levels were lower and the geography of the region was substantially different from today. This civilization developed advanced knowledge in mathematics, astronomy, medicine, and engineering. It maintained an extensive maritime trade network. It was based on sophisticated urban centers that reflected advanced organizational and architectural knowledge. Approximately 12,800 years ago, catastrophe struck. A cosmic impact triggered climate chaos. Sea levels rose. The geography that had sustained the civilization became uninhabitable. The coastal regions were flooded. The established trade routes became impossible. The civilization was destroyed. Most of the population perished, but some survived. The survivors dispersed. They carried with them the knowledge that had been accumulated over generations. They spread across the Indian Ocean, establishing colonies in strategic locations. In the Indus Valley, in Egypt, in Southeast Asia, in East Africa, each colony was established by survivors who brought knowledge and organizational capability from the parent culture. Each colony would develop distinctive characteristics over time, but each preserved core knowledge inherited from Lemuria. These colonies became the centers of the ancient civilizations we study. The Indus Valley Civilization, Egypt, Mesopotamia, the cultures of Southeast Asia. They emerged suddenly and fully formed because they were established by people who already knew how to build cities, how to organize complex societies, how to conduct astronomy and mathematics. They weren't independent inventions. They were transplanted knowledge systems. Over subsequent millennia, these civilizations developed. They mixed with local populations. They adapted to local environments. They developed distinctive traditions and practices. The connection to the original source, Lemuria, was gradually forgotten. What had been remembered as history became mythological. The survivors became gods. The knowledge became sacred tradition. But the knowledge persisted. This hypothesis accounts for multiple observations. The sudden appearance of sophisticated civilizations in multiple locations. The similarities in knowledge and practice across supposedly independent cultures. The anomalies in the archaeological record, achievements that exceed what we think ancient cultures should have been capable of. The presence of advanced knowledge preserved in religious and cultural traditions. The distribution of linguistic and genetic evidence suggesting population movements from a central source. The myths and legends describing sunken civilizations and survivors dispersing across the world. It accounts for these observations better than conventional narrative does. Conventional history treats each anomaly in isolation, creating an incoherent picture. The Lemuria hypothesis creates coherence. It explains why things are the way they are, why ancient knowledge seems impossibly advanced, why similar principles appear across cultures, why myths describe the same events across the world. Science and scholarship are institutions. They have momentum. They have established frameworks. They have people invested in current models. This isn't cynicism about science, it's realism about how human institutions operate. Once a consensus forms, revising it becomes difficult. Not because the people involved are dishonest, but because institutions resist change. A scientist built a career defending a model. That scientist has published papers based on that model, has trained students in that model, has invested their reputation in that model. When evidence emerges that suggests the model might be incomplete, that scientist has reasons, professional, financial, psychological, to resist that evidence, not consciously, usually. But the resistance happens. Academic journals maintain standards. They reject papers that don't fit established frameworks more frequently than papers that do. This isn't conspiracy. It's normal editorial practice. The reviewers believe in the established framework. They're skeptical of alternatives. A paper challenging the framework faces higher standards. Papers supporting the framework face lower standards. Over time, this creates a systematic bias toward maintaining the status quo. Educational systems train people in established frameworks. A PhD student learns a model. They spend years learning it, becoming expert in it, seeing how it explains things. Their dissertation is based on it. Their first papers are based on it. By the time they enter the profession, the model is internalized. It feels like reality, not provisional understanding. They pass this to their students. The model is maintained through generational transmission. Funding flows toward research, supporting established models. Agencies that fund science are staffed by scientists trained in current frameworks. They fund research that builds on established knowledge. Research that proposes alternatives struggles to get funding. The researchers who pursue alternative frameworks often find themselves without resources, without institutional support, without platforms to share their work. This is how institutions maintain continuity. This is how knowledge is preserved and built upon. But it also creates rigidity. It creates barriers to paradigm shifts. When evidence emerges that suggests the current paradigm is incomplete, institutions are slow to recognize it. It's not malice, it's structural inertia. Understanding this helps us understand why evidence for Lemuria hasn't been championed by mainstream institutions. Not because the evidence doesn't exist, not because there's a conscious cover-up, but because the evidence challenges established frameworks, and institutions resist challenges to their frameworks. This also suggests what would be required to shift consensus. It wouldn't be a single dramatic discovery. It would be accumulation of evidence that can't be ignored. It would be younger scientists, less invested in current models, championing new frameworks. It would be funding and institutional support for alternative investigations. It would be educational integration of alternative perspectives. It would be media attention and public interest. Change in institutions happens when it becomes more costly to maintain the status quo than to change. When anomalies accumulate, when younger people, unburdened by investment in current models, see the new framework as more coherent, when institutions recognize that maintaining the status quo is undermining their credibility, change happens, but it happens slowly. If Lemuria existed, if it was destroyed, if survivors had to rebuild civilization in new locations, this changes how we understand human history. It reframes the narrative of progress. Instead of linear advancement from primitive to advanced, we have cyclical cycles. Advancement, destruction, rebuilding, loss of knowledge, preservation of fragments, slow recovery. This makes us humble. If advanced civilization can be destroyed, what prevents us from the same fate? We think we're protected by technology, by modern society, by the stability of current conditions. But Lemuria was probably more technologically advanced than we are now, and it was destroyed. The environment was disrupted, the climate changed, the geography shifted. Everything that supported civilization was destabilized. Are we protected from similar catastrophe? We have technology, we have global communication, we have institutional knowledge. But we're also dependent on stable climate, stable geography, reliable resources. We're dependent on infrastructure that took generations to build. If that infrastructure were disrupted, how long would modern civilization persist? Understanding Lemuria suggests that human civilization is more fragile than we typically acknowledge. It suggests that knowledge is precious. That what we preserve physically, culturally, intellectually matters for what future generations can achieve. It suggests that building for the long term, preserving knowledge multiple ways, maintaining resilience, is crucial. If prehistorical civilizations possessed sophistication we don't typically credit them with, this changes how we understand human potential. It suggests that intellectual capacity and capability are perennial aspects of humanity, that humans have always been capable of sophisticated thinking and cultural achievement, that what we achieve now isn't uniquely modern, it's what humans are capable of achieving under favorable conditions. This has implications for how we treat non-Western knowledge systems. If ancient Hindu, Egyptian, and other traditions preserve inheritance from sophisticated predecessor civilizations, then that knowledge deserves respect. That knowledge should be studied not as curiosities or primitive beliefs, but as potentially preserving understanding that was lost when those civilizations dispersed. It has implications for how we approach contemporary knowledge. If civilization can be destroyed and knowledge lost, then diversifying how we preserve knowledge matters. Maintaining multiple formats: written, digital, oral, practical, maintaining knowledge in different locations, ensuring that knowledge isn't dependent on vulnerable infrastructure. It has implications for how we think about human nature. We're not simply clever animals that recently developed intelligence. We're not the culmination of progress. We're participants in a cyclical pattern. We build, we achieve, we lose, we rebuild. Understanding this gives us perspective. We're neither the peak of human achievement nor living in decline. We're living in our moment in an ongoing story. Somewhere beneath the Indian Ocean lies evidence. Maybe direct evidence of Lemuria. Maybe evidence of other civilizations we haven't yet imagined. Maybe evidence that transforms our understanding of human history. The evidence is there. We just haven't found it yet. Or we've found it and haven't recognized what we're looking at. Underwater archaeology is in its infancy. We've only systematically explored a tiny fraction of the world's oceans. The technology exists to search more thoroughly: sonar mapping, submersible exploration, robotic investigation, autonomous underwater vehicles. Each advance in technology opens new possibilities for discovery. Each year, the techniques improve, the costs decrease, the capabilities expand. In the next decades, we'll discover more underwater settlements. We'll find evidence of more ancient maritime civilizations. Some discoveries will confirm conventional historical understanding. Some will challenge it. Some will raise new questions we don't yet know to ask. The ocean floor will tell us stories. We just need to listen. Genetic analysis continues to improve. DNA can be extracted from bones and artifacts. Population history can be reconstructed from genetic evidence. Migration patterns can be traced. Population admixture can be identified. As techniques improve, we'll be able to trace human movements with greater precision. We'll be able to identify populations that mixed with existing groups. We'll be able to follow the genetic signature of dispersed populations. Linguistic analysis can reveal connections between languages separated by distance and time. Comparative analysis of vocabulary, grammar, and sound patterns can reveal common origins. Language families can be traced back toward common ancestors. Advanced analysis might reveal connections we haven't yet recognized, might trace Dravidian languages to connections with other language families, might reveal the path of linguistic transmission during ancient dispersals. Architectural and symbolic analysis continues to deepen. Researchers are mapping patterns of geometric principles across monuments. They're decoding symbolic languages. They're revealing connections in sacred geometry. As more structures are systematically analyzed, more patterns might emerge. Connections might become more obvious. The transmission of knowledge might be revealed through analysis of architecture and symbolism. Ancient texts continue to be studied and reinterpreted. Improved translation, deeper historical contextualization, recognition that texts might be preserving historical information in encoded forms. As scholarship deepens, ancient texts might reveal more about the past. References to Lemuria might become clearer. The timeline of events might be reconstructed. The story preserved in texts might align more clearly with physical evidence. Radiocarbon dating continues to be refined. New calibration methods, more precise measurements, better understanding of the assumptions underlying the technique. If dating methods can be improved and refined, chronologies might shift, anomalies might be accommodated, the timeline of human civilization might expand. What seemed impossible under one dating scheme might become possible under another. There's evidence waiting to be found. There are anomalies waiting to be explained. There are patterns waiting to be recognized. The next generation of researchers, applying improving techniques to ancient questions, will make discoveries. Some will confirm the Lemuria hypothesis. Some might refute it. But the discoveries will change our understanding. They'll force reconsideration of how we understand the past. When new evidence emerges, institutions need to be ready to receive it. That means creating flexibility in how we approach established knowledge. It means maintaining openness to alternative frameworks while maintaining rigorous standards for evidence. It means being willing to revise understanding when evidence demands it. Scientific institutions could become more open to genuinely alternative frameworks, not pseudoscience or unfounded speculation, but systematic investigation of alternative hypotheses. Funding could support research testing alternative models. Journals could create space for papers challenging established frameworks. Universities could hire researchers pursuing unconventional questions. This would require conscious institutional choice. It's not default, but it's possible. Genuine interdisciplinary dialogue would help. Geologists, archaeologists, linguists, geneticists, historians. These specialists often work in isolation. They don't fully engage with specialists from other fields. A geologist's expertise in ancient sea levels might not be adequately integrated with archaeological understanding. A linguist's analysis of language families might not be integrated with genetic evidence. Creating structures for genuine interdisciplinary dialogue would allow more complete understanding to emerge. Educational systems could shift toward presenting history as provisional understanding rather than settled fact. Textbooks could acknowledge uncertainty. They could present alternative frameworks alongside conventional understanding. They could teach students that history is subject to revision as new evidence emerges. This would prepare students to engage with paradigm shifts. It would reduce the psychological resistance people experience when their foundational understanding is challenged. Funding independent researchers alongside institutional academics would create space for alternative perspectives. Not all good research happens within universities or established institutions. Some happens in independent settings, or in non-Western institutions, or in alternative educational structures. Diversifying funding sources would ensure that research exploring alternative frameworks could proceed. Media institutions could present emerging evidence responsibly, with appropriate skepticism about sensationalism, but without reflexively dismissing alternative narratives. When new archaeological discoveries are made, they could be reported with attention to how they relate to existing frameworks and how they might require revision of understanding. Public engagement with science would help, helping non-specialists understand that science is a self-correcting process, not a body of settled truth. Helping people understand uncertainty, helping them understand that scientific consensus can shift. This would reduce the sense that questioning scientific authority is inherently anti-science. It would help people understand that genuine scientific thinking requires willingness to revise understanding. Perhaps most importantly, institutions would need to develop psychological resilience regarding paradigm shifts. To understand that revision of understanding isn't failure. It's part of how knowledge progresses. It's how institutions strengthen, not weaken. The institutions that rigidly defend established frameworks against evidence become irrelevant. The institutions that can flexibly integrate new understanding become more credible and more valuable. The work of paradigm shift is collective work. It requires multiple institutions, multiple communities, multiple approaches, all working toward deeper understanding. It requires individual researchers willing to pursue alternative frameworks. It requires students willing to engage with unconventional questions. It requires media willing to report on emerging evidence. It requires public interest and engagement. It requires patience. Paradigm shifts take time. But the outcome, if we're successful, is deeper understanding, more adequate explanation of the world, greater ability to answer the questions that genuinely drive human curiosity, a clearer understanding of who we are and where we come from, a more mature understanding of human civilization and human potential. You've been on a journey through this documentary, a journey through geology, through archaeology, through ancient texts and symbols and knowledge. You've encountered perspectives that might be radically different from what you've been taught. That can be disorienting. It's natural to feel cognitive dissonance, to feel resistance, to want to dismiss what you've heard and retreat into familiar understanding. That dissonance is worth sitting with, not dismissing, not accepting uncritically, but genuinely sitting with, allowing yourself to consider the possibility that what you've been taught might be incomplete, that institutions can be mistaken, that our understanding of the past might be inadequate, that there might be genuine mysteries about human history that haven't been resolved. What matters most isn't whether you end up believing in Lemuria specifically. What matters most is that you recover something that institutions often teach out of you: wonder, genuine curiosity, willingness to ask questions and follow evidence, willingness to change your mind when evidence demands it, willingness to sit in uncertainty rather than demanding premature closure. Wonder is what drives understanding forward. Curiosity is what motivates investigation. Humility about our current knowledge is what allows us to discover new knowledge. If you've experienced any of these during this documentary, then something valuable has happened, regardless of whether the specific claims about Lemuria are ultimately proven true. Think about how you look at the world differently now. You see monuments, and you wonder about the knowledge embedded in them. You hear ancient myths, and you wonder about the history they might be preserving. You encounter geological formations, and you wonder about what they reveal about the past. You see patterns of knowledge and practice across cultures, and you wonder about transmission and connection. This wondering is valuable. This is the scientific mind at work. This is how understanding advances. The invitation is to maintain this wondering, to engage with evidence critically, not to accept everything presented in documentaries or media uncritically, but to investigate further, to seek out sources, to think for yourself, to form your own conclusions based on engagement with evidence rather than deference to authority. This is genuine intellectual autonomy. This is what education should develop. The most important outcome of this documentary isn't that you believe in Lemuria. It's that you understand you're capable of thinking for yourself, that you're capable of evaluating evidence, that you're capable of recognizing when institutions might be incomplete in their understanding, that you're capable of wonder, that you're capable of recognizing genuine mysteries and pursuing them with intellectual integrity. Engage with this perspective. Don't dismiss it, but also don't accept it uncritically. Ask questions, seek evidence, look at the sources, think about what makes sense, come to your own conclusions, and most importantly, maintain your curiosity. Keep wondering, keep asking questions, keep recognizing that reality is more mysterious than institutions typically acknowledge. We return to where we began, the question that nobody asks. What if everything we've been taught about Earth's ancient past is incomplete? We've spent this documentary exploring that question. We've looked at geological evidence. We've examined archaeological anomalies. We've studied ancient texts. We've traced patterns of knowledge and culture across the world. We've proposed a framework, the Lemuria hypothesis, that accounts for more observations than conventional history does. Whether Lemuria existed exactly as proposed in this documentary doesn't ultimately matter as much as understanding something more fundamental. Our knowledge of the past is provisional. It's based on interpretation of evidence. It's subject to revision as new evidence emerges. The institutions that claim certainty are often protecting established positions rather than pursuing truth. This pattern, the tendency to defend established frameworks against inconvenient evidence, repeats throughout history and continues in our contemporary moment. We see it in how institutions respond to evidence that challenges their positions. We see it in how alternative perspectives are dismissed without serious engagement. We see it in how young people with unconventional ideas are discouraged from pursuing them. The pattern is institutional resistance to paradigm shifts. Understanding this pattern doesn't make us cynical about institutions or knowledge. It makes us realistic. It helps us navigate between naive credulity, accepting everything institutions say because they claim authority, and reflexive skepticism, dismissing all institutional knowledge as corrupted. We need to think independently. We need to engage with evidence. We need to form our own conclusions. Lemuria, whether it existed or not, serves as a lens through which to view this process. It's a thought experiment about what happens when we pay attention to anomalies, when we notice patterns, when we ask questions institutions don't want asked, when we follow evidence, even if it leads to uncomfortable places. Through Lemuria, we learn something about how knowledge works, how understanding progresses, how paradigm shifts happen. The real lesson of Lemuria isn't about a specific lost continent. It's about human understanding itself. It's about how we learn about the world, about how we can be wrong and not know it, about how institutions can unconsciously suppress evidence, about how knowledge can be lost and recovered, about how the same intelligence that built civilizations in the past lives in us now. As you move forward from this documentary, the invitation is to carry with you the capacity for wonder, to maintain curiosity, to think critically about what you're told, to seek evidence, to recognize genuine mysteries and pursue them with intellectual integrity, to understand that reality is more complex and more mysterious than simplified narratives suggest. To see yourself as capable of discovering truth, not as a passive consumer of knowledge delivered by authorities. The future is written by how we understand the past. If we insist on settling for incomplete understanding, if we dismiss anomalies and suppress questions, then we limit what we can become. If we maintain wonder, if we pursue evidence, if we're willing to revise understanding, then we open ourselves to deeper comprehension. We become capable of solving problems we can't currently imagine. We become capable of becoming more fully human. In searching for a lost continent, we found something more valuable: the capacity to question what we think we know, to see connections others miss, to wonder about a past more profound than we imagined, and to recognize that that same capacity lives in each of us. The capacity to discover, the capacity to understand, the capacity to recover wonder. That is the real legacy, not of Lemuria, but of the possibility that anything might be waiting in the depths, waiting for someone curious enough to look.